Okay, this is the Chapter 3, Chapter 12 quiz review for tomorrow. We're going to start with question number 1. You're asked to subtract these two fractions, and they equal 1. So we're going to get a common denominator here, because in order to combine two fractions, we need a common denominator. So you look at the two denominators, and this denominator, hopefully you can see that it's really x plus 1, x minus 1. Okay, that would allow you to have a common denominator of the same sort for here. So we're going to put an x plus 1 here. We're going to put an x plus 1 here. So now we have a common denominator there. We also need a common denominator over here, and I'm just going to write x squared minus 1 over x squared minus 1 because it's just a little easier to write. So now that we have all the same denominator, okay, so now we have the same denominator across the board. Okay, so we're going to take 2 and subtract it from, so we're just going to solve the top, sorry. 2 minus, this top up here is 1 times x plus 1, so it's, put a parentheses out there, and that's equal to x squared minus 1, which again is 1 times this whole thing. Okay, so this is the new top. That looks a little complicated. You have to remember to distribute this negative sign to both things here. Okay, so our new problem is going to be 2 minus x minus 1 equals x squared minus 1. Okay, so now that you look at this problem here, we've distributed the negative to both entities there. We have to combine like terms, and we can combine these two to get 1. 2 minus 1 is 1. Okay, so we got 1 minus x equals x squared minus 1. Now, since we have an x squared in our equation, you want to put it in standard form. So we're going to send everything to that side, so we can have a 0 over here, a 0 on this side. Okay, so we're going to subtract 1 and add x to this side. Subtract 1 and add x. And I put it like that because I can only combine like terms on the other side. So this side's going to be 0. Okay, so now we have 0 on this side, so we can bring all this down. This x squared can't combine with anything. The ones combine, and we're going to put them on the end. Okay, so now we have a quadratic to solve. So we could use a quadratic formula over here, or we do the triple starts with 3, 2 parentheses. So we look at the negative 2 to add up to 1. And those are going to be, negative 2 to add up to 1 would be what? Okay, so it's going to be 2 and minus 1. So that's plus 2 minus 1 for inside our parentheses. Okay, now, but our answer is going to be the opposite of these. So this is x plus 2 equals 0, or x minus 1 equals 0. So this would be x equals negative 2, or x equals 1. Now these could be the answers, but we still have to do a check. And what we're checking is our original question. We're checking our original question, which is this here. So we're going to put in a negative 2 and square it, and minus 1. Minus 1 over negative 2 minus 1. Does that equal 1? All right, well, let's just do the math here. 2 over 4 minus 1 is 3. So this will be 4 minus 1 is 3. and then minus 1 over negative 3. Does that equal 1? It doesn't look like it equals 1 at first, but if you look, 2/3, if you add the opposite, you get 2/3 plus 1/3, which is 3/3, which is 1, and it checks. Okay, so that one checks. We still have to check the other one. I'm checking the other one, and I'm going to put a 1 in now. I'm going to check x equals 1. And when you put the 1 in, you get 2 over 1 squared minus 1 minus 1 over 1 minus 1 equals 1. Okay? So this is really 2 over 1 minus 1 equals 1 over 1 minus 1. I'm sorry, not equals, minus 1. So basically, you're going to get a 0 on the bottom here and here. So this is not a solution. For this. So we throw out this answer here, and this answer is the correct answer because it checked. Okay, this question's a little bit quicker here. We have common denominators, so we can just solve the top. Now, how do you solve x squared equals 4? You take the square root of both sides. The square root of x squared is x. The square root of 4 is plus or minus 2. So we have two things to check. We can check x equals 2 or x equals minus 2. And you have to show this on the quiz, the checks and your answers. You can't just guess and see what the answers are. So if we put 2 in, we get 2 squared. Again, I'm checking it with the original question. 2 squared, 2 minus 2 equals 4, 2 minus 2. Now you might say, well, yeah, that equals 4 over 0 and 4 over 0, but this is illegal. We can't do that, so this is not a solution. But if we check the other one, the x equals minus 2, and we take negative 2 and square it, and we put negative 2 minus 2 on the bottom, with 4 and negative 2 minus 2 on the bottom of the other, you can see that we have 4 over negative 4, 4 over negative 4, and that does check. So your answer is going to be negative 2, and this one we're going to throw out because it doesn't check. A group of college students, so we're looking at number 3, is volunteering for homes for the community during the spring break. They are putting the finishing touches on the house they built. Working alone, Wade can paint a certain room in 7 hours. So we have Wade who can paint, and we said today put 1 over the amount of time it takes the person to do the job. Rhonda can paint the same room in 5 hours. How long will it take them working together to paint the room? So this runs along the same setup as yesterday when we did this, which is you multiply the fraction times n, and this n is the time, or the total time, I should say, the total time to finish the job. Okay, and we're going to take Wade's time, or Wade's work plus Rhonda's work, and we want 100% of the job done, or we want these two fractions to equal 1 for 100% of the job to be done. Okay, so we're going to do the same thing as we learned at the beginning of the week here. We need a common denominator. So we'll have n over 7 plus n over 5 equals 1. The common denominator is 35. Okay, so we're going to have 5 over 5 times that side, and 7 over 7 times this side, and that's going to give us 35 over 35, or the 1 times the 1. Okay, so now we have common denominators, so we can just solve the top. And we get 5 and 7 is 12n equals 35. So it's going to be like 2 point something. So n equals 35 divided by 12. And if you do that on your calculator, you're going to get, someone said 2.92. So we get 2.92. So we have to, since this is a word problem, we're going to write the answer. It will take both, let's say, students working together. Sorry for my writing. Students working together 2.92 hours to finish. A yogurt shop offers 6 different flavors of frozen yogurt and 12 toppings. How many choices are possible for a single topping, or for a yogurt with 1 topping, sorry. Okay, how many choices are possible for a single? All right, so this is a basic counting principle question. So we have your yogurt you have to choose from and your topping. So you have 6 different flavors times 12 different toppings, and that will give you the amount of combinations of yogurts that you can get. So 72 different ways you can arrange a yogurt in a topping. Suppose Ruth Ann has 3 routes she can choose from to get from school to the library and 5 routes from the library to her home. How many routes are there for Ruth Ann's school to her home with a stop at the library? So you could draw a tree diagram for this. You have route 1, 2, and 3, and each of those routes could have 5 routes from there. Okay, now you could draw that, or you could use the counting principle that we just saw and say, well, there's 3 routes to start, and then I can branch that off into 5 more for a total of 15 routes. Okay. So if we look at the next question, it asks for 12 basketball players listed in a program. How many ways can we arrange that?
This would be
Okay, so I have 12 basketball players listed in a program. So there's going to be 12 spaces to fill. And I'm running out of room here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places to fill. So you wouldn't draw a tree diagram with 12 spots and then 11, and it just doesn't make sense that way. This is a permutation question, so this is 12 things permutated 12 in 12 spots. Okay, so 12p12 is really 12 times 11 times 10 times 9 times 8 and so on, which is really 12 factorial, which on your calculator you can use and you'll get. Okay, so that's the answer to that. So that's the answer to that. Moving on to question 7. Okay, how many different arrangements can be made with the letters in the word power?
This is so easy.
Okay, so power has 5 letters in it. Okay, and we're arranging those 5 letters in a row. So there's 5 choices for the first letter. 4, 3, 2, 1. So this is basically 5p5, which is 5 factorial, which is. So this is just 10p8. You can do it on your calculator, and you get 1,814,400.